Hope you are all doing well. Today we are going to see an important theorem from 10th class, triangles. The theorem number 6.1. So what is the theorem? Let me read it out to you. If a line drawn parallel to one side of a triangle to intersect the two other sides in distinct points, the other two sides are divided in the same ratio. Just observe this triangle. There is a triangle and a line is drawn that is parallel to BC. D is drawn parallel to BC. Then what does this DE do? DE intersects the other two sides in the equal ratio, in the equal proportion. It is very simple to understand. There is a triangle. If you take a triangle ABC, we have drawn DE and DE is parallel to BC. DE is parallel to BC. Then DE will cut these two sides in the equal ratio or in the equal proportion. That means AD by DB is equal to AE by ECE. That's it. So what is before going into the proof of this theorem, this is one of the important theorems for the chapter triangles, and the whole triangle chapter revolves around this particular theorem. So it's very important to understand this particular theorem. This theorem also called as Basic Proportionality Theorem or Thales Theorem. Okay, so you just remember Basic Proportionality Theorem, BPT. So in this BPT, to prove BPT, what is given to us? There is a triangle and there is a line DE that is parallel to BC. That is given to us. Then what is to be proved? What is to be proved? This DE will cut the other two sides in an equal proportion. That we have to prove. So let me write here given. So what are the things that are given to us? ABC, AB, triangle ABC. So DE is parallel to BC. That is given to us. That is given in a triangle ABC. We have constructed DE. D and E are two distinct points, and DE is parallel to BC. So what is to be proved? What is to be proved? If DE is parallel to BC, then our proof is DE is cutting two other sides. AD by DB is equal to AE by EC. So we have to prove this. This is to be proved. So DE is parallel to BC, then we have to prove this. So how are we going to prove? So before proving, so let me give you a kind of a small construction. So what is our construction? So we are going to do some construction. So what is this construction? We are going to draw a perpendicular line here. We are going to draw, this is, let us say M, this is N. So we are drawing perpendicular lines. Draw perpendicular lines to AD from E, and draw perpendicular to AE from D. That is the one construction we did. And one more construction what we are going to do is we are going to join DC and DE. Join DC and BE. This is how we have constructed this. So once we construct this, then depending on this construction, we are going to prove. So what is the area of triangle ADE? So in general, what is the area of triangle? Half into base into height. Half into base into height. Let us see the triangle ADE. In triangle ADE, what is the area of the triangle ADE? Half into AD into EM. Half into AD into EM. So let us take the triangle. The triangle area of triangle ADE. What is the area of the triangle? Half into base into height. Here half into, what is the base? Base is AD into EM. EM is the perpendicular, that is the height. EM. Very good. So give me again, once again, area of the triangle ADE with respect to the base AE. If AE is the base, what is the area of the triangle ADE? Triangle ADE, look at the triangle ADE. ADE half into AE into DM. Half into AD into DM. This is very, very simple. You should know the area of the triangle. That's all. Area of the triangle ADE, half into AD into EM. Area of the triangle ADE once again, half into AD into DM. Very good. So now give me the area of the triangle BDE. What is the area of the triangle BDE? Half into, take the triangle, look at the triangle here, BDE. BDE is an obtuse angle triangle. In an obtuse angle triangle, I am just writing here. So just imagine this is an obtuse angle triangle. Obtuse angle triangle. If there is an obtuse angle triangle like this, we cannot have a height. So to calculate the height, we draw a perpendicular from the. So let us say it is a ABC is an obtuse angle triangle. This is the height. We extend BC this side, then we draw a perpendicular, then this is the height. So look at here, DBA is an obtuse angle triangle, so we extended BA, then we draw from vertex to EM. Now let me give you half into BD into half into BD into height will be EM because this is an obtuse angle triangle. So once again area of triangle, let us take this triangle CDE. Let us take the triangle CDE. So what is the area of the triangle CDE? Again, the base is EC. The base is EC. CDE. CDE. So the base is EC. Then we extended here. Again, we have drawn a perpendicular here. Then what is the area of this triangle? DC with the base EC into DN. Did you understand it? Very good. So we have seen the area of the triangle ADE and we have seen the area of the triangle DBE and we have also seen the area of the triangle DEC. So we have seen this much. So let me now give a little more little bit of comparison of. So what I am going to do is I am going to take a ratio of this two and another ratio of this two. So I am going to take triangle ADE, area of the triangle ADE by triangle, area of the triangle CDE, and triangle ADE by triangle CDE. ADE by BDE, ADE by CDE. That's what I am going to take. Okay. So that we have taken area of the triangle ADE by area of the triangle BDE, half into AD into EM by half into BD into EM. Again, area of the ADE by area of the CDE, ADE half into AE into DN by half into EC into DN. So let us see here. When there is some common elements here. Okay. In this equation, half of chalega. Very good. So what do we get here? So let me write it. Okay. Here what am I getting here and what am I getting here? Let us see. What am I getting here is equal to AD by BD I am getting here. Here I am getting AE by EC. I am getting AD by BD is equal to AE by EC. So I am getting this. So I wanted to tell you something more. What are the areas of triangles? Here are area of triangle, area of the triangle BDE, and area of the triangle BDE and CDE. What is this? The area of the triangle BDE and area of the triangle CDE equal. How they are equal? So imagine D is parallel to BC, and on a single base we are making one triangle here. On a single base we are making a triangle here. When you are constructing a triangle on a single base between two parallel lines, those triangles will be equal in area A, B, C, D, because the height of the triangles here BC is AD and BC are two parallel lines. Then BC is a common base. On a common base, if you make 100 triangles between two parallel lines, they will be equal in area. Here look at it. AD and BC are two parallel lines. I am constructing ABC and BDC and BPDC. सबका बेस सेम है, सबका हाइट सेम है, सबका बेस सेम है, हाइट सेम है. If height is same, base is same, then areas will be equal. These two triangles areas are equal. If these two triangles areas are equal. If the two triangles areas are equal, imagine just look at again ADE by BDE, ADE by CDE. But we are proving that BDE is equal to CDE in area. Got it? So ADE by BDE. ADE, BDE. So why this is triangles between parallel lines. Triangles on same base between parallel line. So very good. So what we have seen, so now we can say the area of ADE by BDE, ADE by CDE, and these two equations are equal because ADE is ADE and BDE is CDE. BDE and CDE are equal. equations are equal, that means equation 1 and equation 2 are equal. If the two equations are equal, then what happens? AD by BD is equal to AE by EC. So therefore, if these two equations are equal, if the two equations are equal, then AD by BD is equal to AE by EC. Just go and say what is to be proved. What is to be proved? To be proved is AD by BD is equal to AE by EC. AD by DB is equal to AE by EC. So this is in a triangle. If there is a line DE that is parallel to BC, then this DE will divide the triangles, the other two sides, in the equal proportion. That is AD by DB is equal to AE by EC. AD by DB equal to AE by EC. Hence proved. Hence proved. Hence proved. Hence proved. So we have proved this theorem. So what is the crux of the theorem? There is a triangle. There is a parallel line. There is a parallel line. That parallel line is to which? Third side. And if that is the third side, parallel to the third side, that particular parallel line will intersect the two other sides in the equal proportion. AD by DB is equal to AE by EC. This is called Basic Proportionality Theorem. If you understand this theorem, whole your triangle chapter is a cakewalk. Otherwise it will be difficult. And it is very easy to understand. Understand step by step. And don't forget, the area of the triangles on the same base between two parallel ends is equal. That is there. That's why triangle BDE and triangle DCE areas are equal. And one more thing you should remember, obtuse angle triangle. BDE is an obtuse angle triangle. Then how to find out its area? Then we have drawn a perpendicular. So therefore, half into dB into HEM. Half into dB into EM. That is the area. These 2 points you should remember. If you remember, you can solve this, you can prove this theorem 6.1. This is called Basic Proportionality Theorem, BPT, Basic Proportionality Theorem, Theorem. Thus, we have proved it. Bye-bye.